This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Lesson 10. The Week 4 Capstone. No new theory. You already own the toolkit. Shafts and keys, bearings, power screws, spur gears, the helical, bevel and worm family, planetary trains, belts and chains, and clutches and brakes. This lesson is about using it under exam pressure, naming the power transmission element in seconds, clearing the gate it hides, reaching for the right relation, and checking before you commit. We'll run 4 fast problems that span the week, then lock in the lookup discipline, the units, and the traps. The method first. Every week 4 question is a power transmission element hiding a gate you clear before any formula. Shafts and keys, power fixes the torque, and the key force acts at the radius, 2T/d. Bearings. There's no single stress. Size on the load life curve and fold any axial thrust into the equivalent load first. Gears. The tangential load comes from power. The helical, bevel, and worm gears add a thrust the bearings carry, and a planetary set is matched to a printed figure. Belts and friction drives. Friction pins the tension ratio in radians. The net pull does the work, and a clutch or brake is a friction annulus. Name the element, clear its gate, and the relation is forced. Problem 1. Shafts and keys. Recognize the chain. Power fixes the torque fixes the key force at the shaft radius, and the key gets 2 checks. The rotary power relation gives about 2100. The key force is 2T over the diameter, about 2400. Shear across the full width passes near 6 1/4. Bearing on half the height is tighter at 5.6, so bearing governs. Take the key force off the radius, never the diameter. Problem 2. Bearings. A rolling bearing isn't sized by a stress. It's a load versus life curve, and a combined load folds into one equivalent radial load first. Convert the life to millions of revolutions, 720. Build the threshold from the thrust ratio against the static rating. The thrust ratio clears it, so the thrust counts, fixing X and Y. Assemble the equivalent load, then the life law gives a required dynamic rating near 18,500. Keep the static and dynamic ratings straight. One sets the factors, the other is the answer. Problem 3. A gear train, 2 moves. First, a spur pinion's tooth load comes from power, not from the resultant. Pitch line velocity needs the diameter in inches. Then the transmitted load is 33,000 times horsepower over that velocity, about 630, and the radial force follows from the pressure angle. Second, the planetary reduction. Don't derive it, match the figure. A planet rolling around a fixed central gear with a driving arm is figure 1. F equals 1 plus C/B. The planet spins 5 times per turn of the arm. Match the fixed member, driver and follower, before you trust a formula. Problem 4. A belt drive. Friction sets the ratio of the 2 strand tensions, and only their difference does work. Start with the small pulley wrap, the smaller of the 2, kept in radians. The friction ratio is E to the mu theta, so the slack tension is the tight tension divided by it. The net pull is tight minus slack, and the power comes from that net force at the belt speed, about 20. Radians, the small pulley wrap, and the net force. Get those 3 right, and the belt is done. Lookup discipline, where everything lives. All of power transmission sits in one handbook block. Bearings, then power screws, then shafts and keys. The whole gear family across a run of pages, with the planetary figure page in the middle. Then belts and the chain rating tables, and clutches and brakes to close. Know the neighborhood, jump to the page, read the row, and confirm. Never hunt mid-exam. The units and the clock. 5 unit slips to find this week. The power constant is 63,025 for inch-pounds, 5,252 for foot-pounds. Pitch line velocity needs the diameter in inches. Bearing life is in millions of revolutions. Belt wrap angles go in radians. And clutch and brake D and D are diameters, not radii. On the clock, 80 questions in a single 9-hour session with 1 optional break. First pass the ones you know, flag the rest, and never leave a blank. The week's traps in one screen. shafts, keys, and screws, the right power constant, the key force off the radius, and lead versus pitch on a multi-start screw. Bearings, life in millions, the ball versus roller exponent, and the static rating only sets the factors. Gears, velocity in inches, the tangential load from power, the axial thrust that lands on the bearings, and match the planetary figure before the formula. Belts and clutches, RADIANS, the small pulley wrap, power from the net pull, and each clutch model keeps its own force with its own torque. The Week 4 recap on one screen. 7 element families, shafts and keys sized by stress, bearings by a life curve, power screws trading torque for thrust, the gear family carrying load from power, planetary trains matched to a figure, belts and chains on friction and tables, and clutches and brakes on a friction annulus. And the habit that catches most mistakes in each. Key force off the radius, convert to the equivalent bearing load, tangential load from power, match the planetary figure, and RADIANS with the net pull for belts. You can size every one of them. You're ready. That's a wrap on Week 4, Power Transmission. 10 lessons across the whole chain, shafts and keys, bearings, power screws, spur gears, the helical, bevel, and worm family, planetary trains, belts and chains, and clutches and brakes. Then this capstone tying them together under time. More machine design and materials weeks are on the way. Subscribe so the next one reaches you. Everything's at PEPrepengine.com. A cheat sheet, work solutions, and a short quiz are attached here. If the course helped, please subscribe, and good luck on exam day.
The full study guide, with every equation and common exam trap, is free at PEPrepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.